Testing sound. Let me go take my drink. Okay. Okay, how is the sound? Okay, hello, this is Junichiro Horikawa, and this is the 92nd episode for Houdini Algorithmic Live. This is the tutorial live stream that I'm doing weekly for Houdini. And this is the 19th, and the topic for today is to create this kind of organic branching shape using Vellum simulations to create this outline. And the method is pretty simple. It's all about creating the layers or contours of this shape throughout the Vellum. I'm just going to create the outline or the section drawing cross section of this shape on each frame by using kind of a similar to a differential growth simulations. That's what I'm gonna do using Vellum, and all I need to do after that is to just connect all these contours together to create a lofted shape. That's pretty much it. So it's pretty simple, but you can create this kind of a pretty interesting shape with those easy methods. And by tweaking some of the physical properties of the Vellum, you could change this contour shape as well, which is also pretty interesting to try out, to do an experiment. So let's do that as well. All right, from scratch as always. Okay, so let's do this. And what I'm gonna do is to try to create a geometry node, and the first thing first, what I'm gonna do is to try to create from a really simple shape like a circle. I'm gonna use the 2D curve on a plane, XZ plane, and then try to grow it on a same plane, XZ plane, with kind of a differential growth like a coral shape like simulations to create a coral like shape with differential growth simulations using Vellum. So I'm gonna create the circle with the polygon on XZ plane, then make this open arc or closed arc, maybe open arc, and have as many points as possible. I'm gonna start with 50 points for now. And since when I have created the circle, and by making an open arc, the end point and the starting point is not actually connected, not fused yet. So I'm gonna use the fuse to connect the end point and the starting point for the circle, so that you could have a closed curve. Okay, then in order to create something like a wavy shape for this curve, for this circle when it grows, the in order to make this grow, what I'm gonna do is to try to set the lengths of each edges to be a little bit longer than current lengths. So using kind of a string force, stretching or spring force, using Vellum. And when you do that, it is going to, the force is trying to repel those points to the opposite direction to make this length bigger. So for this edges, this point will try to go this way, this point tries to go this way. All these other edges are doing the same things, and as a result, all the points will try to go outward, like equally in this case, if it's a circle. So if you want to make a wave, then it's better, you do need to have some kind of initial wavy pattern, because if it's a really clean circle, what it all does by making the stretch rest lengths bigger is just making this circle bigger and bigger, and that's it. So in order to make it like a wavy shape, you do need to have some kind of initial wave, so that the direction of the point which pulls to will be it's going to be varied when you have a different direction as a force for every positions. So what I'm going to do is pretty simple. I'm just going to try to move those points randomly to a normal direction. In this case, a points from the center to each of the point. And I'm going to call this as a normal direction. Okay, so first of all, I'm going to create a direction by normalizing the current point position, which is equal to the direction from the center point to each of the point, like this. And then try to move each point by this direction using some kind of random value or noise related value. Either way is fine, I think. Probably might make a different value, different movement. I'm gonna try with the random one, and I'm gonna also try to multiply by some distance value so that you can control how much it offset using this randomness. Okay, just gotta connect this one. Okay, just like this. So it doesn't have to be too big. It just can be merely offsetting like this, like 0.01 or so. Because all you need is a kind of a differential direction for each edges, and that's pretty much it. So I think making this smaller is just fine. If you make it bigger, then that might make you a different result. Might be interesting to try out later. But I'm gonna try with 0.01 for now. Okay, so that's the initial step that I'm gonna do. And the things that I forgot to do is that currently the random vector value, in this case this could be a float value, but I'm not sure, so let's make sure that this random value is a float. By making it, because the same random function could give you a vector value, could give you a float value, and so on. So this is a better way to describe what the variable is. Okay, I wanted to do that because if the random value was vector value, then there's a chance that it goes upward to the y direction, which I don't want. I want to fix this curve onto a xz plane because I do need to have some kind of a collisions in order to calculate or in order to simulate the differential growth like simulations. Okay, I have a question from a Som Kurus. How do you find these algorithms? I don't know. I've been experimenting a lot of algorithm from all those existing examples or research or papers or anywhere, and I'm just combining all these existing algorithms, and that's pretty much it. So it's nothing new here. Just revisiting all the existing cool algorithm that I could use to design something which looks interesting as a shape. Hey, so what's next? The next thing I like to do is making a vellum constraints from this circle. So, given a vellum constraints, connect the curve onto the first input, which gives you an option to choose what kind of constraints you want. The things that I want here for this curve is just a simple one like string. The string constraints will make this curve as a something like a rope-like physical object, which you could simulate like a rope-like simulations using Vellum, which I think is a bit less expensive than other one like cloth, which will enable you to simulate the closed simulations, but you need a mesh. But instead, for this string, you just need to provide a curve. So I think that's a bit low cost in terms of the calculation. Okay, so I don't really need to touch any of those values right here, because I'm gonna dynamically change those values inside the Vellum Solver. So I'm gonna just leave these as it is for now. I'm just going to set the group for stretch and debend. That's it for now. I'm gonna set the stiffness for a stretch and bending stiffness to be as default value, and see what happens at this point. Okay, now I'm going to connect the Vellum Solver like this, and since I want to fix this curve on top of the XC plane, I don't really want to move it like on y direction, either on positive or negative. So I could check the ground positions for 0, 0, 0, or I could force the curve to be on top of the plane inside the solver. So I'm gonna do like that. And I don't really need a gravity, so I'm gonna set the gravity value to 0. And wind is already 0, so that's good. Okay, so that's it for the setup for these component or node. Let's go inside, and what I'm gonna do is to first of all try out what will happen when I increase the rest length of this curve for each frame, to see if it's really going to create something like differential growth like simulations. So to try that out, the easiest way is to use the Vellum constraint properties, connect it to the source, and then check the rest length scale, and for the group equal to stretch, because I just want to control the stretch constraints, which is controlling the length of each edges. So by increasing this rest length scale for each frame, you'll be able to somehow grow these curves on each frame, which in turn will give you some kind of a growing snake-like simulations, which will try to collide to each other, self-collide to each other to create a differential growth like simulations. So let's try making this 1.1, something like that, for rest length scales and try to simulate it. See what happens. Okay, so something has happened, but it just grows once for a single frame and that's it. So if I want to see this grow over time, slowly, gradually growing over time, then I should increase this value from 1 to some goal value until the end. So I'm gonna try to write some expressions here. So current frame divided by frame end will give you a value in between 1 to, 0.0 something 1 to 1. So close to, or shall I just say something like that, so that it will give you a value in between 0 to 1, is it? No, actually not. I'm gonna go like this. So, well, this will give you a value somewhere in between 0 to 1, okay, from the first frame to the end frame. And this will, so the result of this scale is going to be from 1 to 2 from the first frame to the end frame. So let's see what happens with this setup. I play it, so it's growing slowly over time. Now it's not really changing its direction that much, it's just growing as a circle. Seems like the offset between the edges were not enough, making the direction goes to only to the outward direction. So in order to fix that, I can try to make this offset value a little bit bigger, something like that, like 0.1. See what happens if I play it. Not so much yet. Yeah, not so much. Okay, let's try with a lot more constraints. And one thing I might also need is to create a angle rest length so that it's try to flatten out. So because right now the there's two types of constraints for this string constraints here. One is the stretch, which I was controlling. If I look at the primitive from this second output, there's a stretch group which is called as distance as a type, and the rest length is the actual length of these edges. Let's make this a bit smaller. Now there's other constraints here for the string, which is, if But if you go down, which is called as bend, and the type is called angle. And if you look at the rest lengths, it gives you a value in between 0 to something like 90 or 180, which is seen as a degree, an angle degrees. Okay, so this is controlling these angle here. So in order for you to create this kind of the differential growth like simulations, I think you also need to control this rest length or rest angle for this bend type constraints. So let's also try to do that by going back to inside the Vellum Solver. I'm going to copy this Vellum constraints, and this time I want to control the bend type, and for the rest length, going to change the constant value something smaller like 3, and see what happens. Now that wasn't, now it gives you a cleaner edge, but maybe that wasn't enough. Maybe I should also make this thing faster, like multiply by 5 or something. Or 10. Let's see. Okay, starting to give you some wavy pattern. So probably the growth speed is also pretty important here, as well as this angle. But what if I turn off this angle? Let's see what happens. Still does give you a wavy like pattern, but as you can see, the edges is not that clean in terms of the angle. So it is still a good idea to have this angle constraints manually set or dynamically set to control the smoothness of these angles. Right, now let's try to speed this up a little bit more to see what would happen. Right, now by making it bigger, there is one problem starting to happen, which is that you see that the resolution is getting lower and lower because I'm just using the same number of points for the circle, which gives you, if it becomes larger, then the number of the point is not enough to create a smooth curve. So you do need to rebuild the curve or resample the curve at some point to make it smoother in order to have a more larger scale curve. You can do that either by just set the initial curve to have more points, like starting from 1000 points, which will enable you to create a curve with high resolutions, but the downside is that right now I think it's a bit too fast. The downside is that by having tons of points initially, it will make the simulations pretty slow from the first frame, which might not be ideal most of the cases. Which looks pretty fast still. Like that. So what I would like to do is to starting from a really low res curve and then gradually resample the curve or rebuild the curve to have a more points based on the length of the curve for each frame, so that gradually it can grow the number of points and gradually it becomes slower to calculate but create high res result. Okay, so that's what I would like to have, and in order to do that, let's go back to the circle and start from number of points with 50, and probably maybe using randomness might not be a good idea because it's might be too jaggy here. So instead of randomness, I'm going to try to use noise function to have a little bit smoother randomy wave with a smooth parameter inside for the noise together with the point position. Okay, let me increase the seed value here. Somewhere around here. Try to make it smooth as possible. Maybe somewhere around here, not sure. Yeah. It's not that different from the randomness, I guess, but let's try it with these. See how it goes. Right now, so in order to rebuild the curve within the Vellum Solver, what you need to do is go inside the Vellum Solver, and instead of using this Vellum constraint properties, I'm going to recreate the curve, meaning resample the curve to create the new curve with the new points, then rebuild the constraints itself. I mean, throw out the old constraints and just recreate the new constraints for each frame. That will give you an option to have a updated constraints with updated points, which can be used to simulate a growing curve with the high res option. So to do that, I'm going to use two subsolver. One solver. This is for the geometry, the curve itself, to resample. And I'm gonna copy this one. And the second subsolver is going to be used to create the constraint and control the constraints stiffness for the stretch and the angle, just like I did here, and connect it here. Okay, that's what I'm gonna try to do. The subsolver will enable you to access either your geometry, which is coming from the first input, or the constraint geometry, which is coming from the second input, this purple one. In order to access the constraint geometry with this subsolver, you just need to type this constraint like this. And this will enable you to access the constraint value or constraint geometry for this Vellum solver. You could bring the geometry later, but I'll try to do like this. First, resample the geometry with this subsolver, then using the second subsolver to control or recreate the Vellum constraints. Right. So let's go inside this first geometry node, then try to create a simple resample node network. It's pretty simple. I'm just going to use a resample node, just like that. I'm gonna try with point 0.1 as a resampling length. Might going to change this later in order to control the resolutions, but let's go with this for now. Now after you have resampled, the number of points will change based on the parameter of this curve. So previously it was 50 points, right now it is 74 points because the length of the curve is a bit longer. Now right after you have resample, you should also do the fuse because the end point and the starting point is again being separated. So you need to combine or merge, weld those points together using this fuse node again. Okay. Now, next thing you want to do is to fix this point position on top of the XZ plane. There is a chance that by using the Vellum Solver, it will self-collide to each other, and some of the point goes up or down based on these collisions. So in order to avoid going these points up or down, I'm going to use the point wrangle to fix the Y value to 0. So that the collision always happens on the 0 plane, XZ plane. Okay. And also, I'm gonna try to set another properties for each point, which is going to be used as a collision radius, self-collision radius, which you can use Pscale for that. So this Pscale value is going to be used as a collision radius for each of the point. So it will going to used to collide these edges together so that it will not override other curve or intersect to other curve. So let's try to make this bigger than the sampling lengths, because right now the lengths between those points are equal to 0.1. So the collision radius I think is going to be larger than 0.1, because if it's smaller, then there is a chance that there's a gap between each collisions on each point, which make this gap to enable other curve to penetrate or intersect. Okay, so for myself, I'm going to try to say 0.3, but could be any value. Let's try to make this parameterized. Pscale. I'm gonna start with 0.3. Right. So that's it for the subsolver, I think. And let's create a output node so that this final node will always be outputted as a result. Alright. So now you should be able to resample these geometries on each frame. So let's see if that happens. If I play it, okay, something is happening here, but don't really need to worry about it. That is because if you look at the error, it says the number of points in the geometry and constraints do not match, meaning you need to recreate the constraints corresponding to the new number of points. So that's what the error is about. So the next thing you want to do is to recreate the constraints inside this second solver. Okay, go inside, and what you're going to do is pretty much the same as you did outside the subsolver, which is using this Vellum constraint to create a string constraint. So I'm going to copy this one, copy this node, go inside the second subsolver, then connect the input to a first input, which is which will give you an error at the moment. That is because what you need to output is the constraint. Okay, why am I having this error here? Invalid source. Okay, so actually this dot geometry will give you a constraint geometry, so this is not what I want as a source in order to create the Vellum constraint. What I need as an input for this Vellum constraint is this circle. Let's go back to the first frame. So this circle here. This curve geometry is the one that I need in order to create the constraints inside the solver, but that's it. That geometry is not coming from this one because I am binding this constraint geometry here. So what I get from here is the constraint geometry, which I don't really need to recreate it. So what I'm gonna do is to import this curve geometry from the first solver by using object merge node, and let's name this curve and go to this solver node, which is under solver 2. I just need to select this solver 2 as it is, okay, which will give you an access to this curve, and then you can connect this to the first input of this Vellum constraints to recreate a new constraint, which is coming from the second output. Let's check it out. Looking into the geometry spreadsheet at the primitive primitive attributes. So you see the distance with the group stretch and angle with the group bend, right? Just like you were seeing outside the solver. Alright, so that's good. And so this is the actual geometry or constraint that I want to output as a result. So connect the output node like this. And by doing that, you should avoid seeing the error anymore. And also the curve is slowly moving. And what I see, the reason why I'm seeing two curves here is I think one of the curve is just a cached one, which should go on by clearing the resetting the simulations, I hope. Nope. I think it's just a cache here, which I don't really know how to delete it, so I'm going to open a new scene view which will remove the cache just like that. Remove the old view. I don't know the other way to remove this cache starting from Houdini 19. This happens to me. I'm not sure if that's the same for you guys. Alright, so going back. So now things are going better. It's time to try to tweak some properties for this Vellum constraints, which you can do it inside this second subsolver for the constraint geometry. Okay, just like I did right here manually. Alright, so right after I created the Vellum constraints, I have these primitive, which have these rest lengths or stiffness, which can be controlled, or which can be like modified using primitive wrangle by yourself dynamically. So that's what I'm gonna do. Okay. And that's the key point for this setup. Okay, so the first thing I would like to try is to increase the stretch rest lengths over time, slowly. Okay, so in order to do that, I am going to create a primitive wrangle. So if you want to control the stretch, then let's keep the accessing group to stretch. Then what I want to modify is this rest length. This is currently the length for each edges, and in order for this curve to grow over time, you need to increase this rest length for each frame. That's what I want to do. And in order to do that, there are many ways, but one of the easy ways is to just scale this value over time with the same scaling factor. Now, this rest length is the actual value which is being considered to define the length of the edge. On the next attribute, there is also a rest length orig, which stands for original. So this is the original rest length value, which is initially same as the current rest length, but this value is not going to change over time. I mean, it's not going to dynamically change, or even if you change this one, it doesn't affect anything. Only this one will affect the value. This is just a kind of a rest position like value. So I can use this to create a new updated rest length value by scaling this rest length original value by some value more than 1 for each frame. To do that, you just need to say rest length is equal to rest length original multiplied by some value more than 1. Let's make this parameterized, shall we? Starting from small value, or I don't know, 1.1, and as a result you see that the rest length becomes a bit bigger than the rest length original, which in turn will give you a longer edge as a physical simulation result. And let's see what happens with this. Okay, going back to the scene view and inside the Vellum Solver, if I play it, hopefully what I see is the curve growing, and yes, it did. And with the value applied to each point as a Pscale, there is a distance between these edges, which is considered as a collisions. And if the Pscale is smaller, then the gap between the curve will get smaller. Let's see. So if I go back inside a first subsolver, go to the set properties, and if I set the Pscale to 0.1, what you see is a bit, not so much. Well, looks the same, isn't it? It's pretty much the same. Looks like, so the edge is around 0.1, so I guess the edge between the edge distance is also 0.1. So I'm not sure if this is really working. Pscale. What if I say 0.5 or 1? Let's see if it's gonna make change. Okay, I do see a little bigger gap than before, but not really directly used as a length, I guess. Not so much. So, well, maybe the value isn't that much important. I don't know, if I set it to 0, what would happen? Okay, so 0, by setting 0, it doesn't give you any collisions, so I guess some kind of a value is important. Seems like. So, what if I set to 5? Yeah. So this value do something. I mean, it's important for a collision, so you do need to have some kind of a value for sure. I'm gonna stick with 0.3 for now, because it looks okay. Okay, so going back to the constraints, and now that I have set the scale for the stretch, next thing I would like to do is to try to control more of a curvature of these growing curve, because right now it's growing okay, but I don't really like what's happening inside here, especially on the middle of this geometry. It's creating more like a snake-like shape, which is not, which maybe is okay for some usability for situations, but for myself, I kind of wanted to have a bit more circular shape over the places, not like these snaky-like shape. So I wanted to keep the profile of these curve everywhere more of a arc-like shape. So in able to achieve that, what I thought that I need to do is to control the angle stiffness or angle rest length. Okay, so that's what I'm gonna do, and that's what I was trying to do here as well, using this manually, trying to control the bending groups rest length. Okay, so by keeping the value equal to 0, it's going to try to keep the angle between the curve flat, like 1, to make these the angle between two edges to be flat. If you make it 90 degrees, then it's going to try to make these angle between the curve like perpendicularly. So keep that in mind. If you set the value close to 0, then you should be able to have more smoother curve, and meaning smaller curvature, meaning larger curvature circle or curvature radius. So that's what I want in order to create a more circular shape all over the places. So in order to do that, I am going to create another primitive wrangle. Next thing I'm gonna try to control is the angle for this bend group, and I'm gonna access these lengths, and I'm gonna try by manually controlling the value equal to 0 for now to see what happens. So remember this result without setting any rest lengths, and if I forcefully set this to 0, let's see what happens. Okay, it didn't really give much difference, I guess. That is because I guess I might also need to control the stiffness, or am I also... I also need to check if the constraint rest length is properly updated. So type angle rest length is equal to 0, so looks like it's okay. But right now seems like the curve is a bit too soft. It just easily bend based on these collisions. So in order to avoid that, I guess I need to go back to the Vellum constraints here, where it creates the bending and stretch. And let's see if I can control the amount of bendiness for this curve, meaning the stiffness of this curve, which is controlled right here. Bend, stiffness, and if let's try to make this a little bit bigger to see what happens. If I set it to 1 times 10, make this harder, the curve to bend. Now it gives you more harder curve, but now the problem is it intersect. Maybe the speed is too fast for the growing. If I set this to 1, still the speed looks a bit too fast. And let's try to avoid using angle rest length for now and see what happens. Okay. Okay, I can see that there is some intersection because from here to here, the growing speed is a bit too fast. So it couldn't collide within this frame. So in order to avoid that, you need to make the growing speed a little bit slower. So going back to the scale, I think I need to make this slower by making this scale smaller. Okay, let's see what happens. Alright, so no more intersecting happening, but still have it. But I still see those snaky edges inside, which I really want to avoid. So let's see if I can avoid this by adding an angle, additional angle rest lengths. Okay. At some point it's getting maybe it's still a bit fast right now. Maybe 0.03. Okay, getting better. Now, one of the reasons why it crashes or changes its shape is because these curves try to grow over time for any places, even inside. So my wish is that if the curve is somewhere close to the center, like these part, which creates a nice little circular shape here, I want to stop these. I want these curve part to stop growing, and only I want to let only those outer lines to grow. I don't want the inner curve to grow anymore for some amount of time. Okay. So initially any curve can grow, but at some of the point, like here, I want to slow down the growth of these curves so that I can keep the shape of these profile a little bit better and try not to crash like these. but I don't really mind changing the outer line, outer curve, because these outer line are still trying to try to create a circular shape. But inside it, just what it does is just collide with other curves, and so that's what I want to avoid. And in order to avoid that, you can do that by try to control the scale value. This one right now, all the edges are uniformly scaling up, but I can calculate the distance from the center to each of the edges, and if the distance is smaller close to the center, maybe I can make this scale close to 1, meaning try to avoid growing at some point. So that's what I would like to try out. Okay. And the problem is you can't really define where is the center of this curve, because you can't really imagine how it's going to grow, because the starting curve is a bit randomish. So I do need to dynamically find the center of this current curve geometry. Then from this center, I need to calculate the outer radius of this overall shape. Now I can use the bounding box, but the bounding box will give you a square shape, which might not be ideal for this kind of a oval shape. So instead of using a bounding box, in order to find out the distance between the points, the maximum distance or minimum distance between the outer positions, instead I'm going to use the convex hull. Convex hull will give you a overlapping geometry, just like that. Just like that. And well, it looks dirty, but it doesn't really matter. All I need is these outer points, and what I want to get is the center of this convex hull, as well as the distance between these points. And what I want to get is the minimum distance out of all those points, and I want to use this minimum points as a threshold to calculate the ratio between the value to see whether the point that I want to set the scale is inside this range or not. Okay, so what I'm gonna do is to connect this convex hull shape to the second input of this scale. Then probably I could also calculate the centroid of this convex hull by using attribute promote to this convex hull, looking at the point position, set this to detail, get the average, and let's call this center. Okay. I also want to calculate the distance between the center to these points, so let's also calculate that. In order to do that, I guess I need to use a point wrangle. First, in order to calculate the distance for each point to the center. So distance is between the detail, the one that I've just created, center, between the current point position. Okay, and apply that to a point attribute. see. What's this? Implicit cast. Okay. It has to be float. And if I look at the point attribute, I have these distance. Now, right now, it's pretty much looks circular, so all the distance pretty much looks the same. Now, what I want to do is to get the minimum out of these list of distance. So another attribute, promote. I'm going to look at the distance for the point attribute and set this to detail, get the minimum, change this to min distance. Alright. Now this is the threshold that I'm gonna use to check whether the point that I want to set the scale is within this convex hull or not, or in what percentage is inside, if it's close to the center or if it's close to the edge. Okay, so going back to the scale, the first thing I want to do is to calculate the distance between the current. Let's say I have calculated this. Okay, gotta make this thing output. Okay, let's say this is the shape that I want to calculate. Okay, and right now the convex hull is like this. Shape like this. And the minimum distance from the center of this convex hull is 5.73. Now what I want to do next is to calculate using the same center point for this convex hull. I want to calculate the distance from the center to each of the point for these current conditions, and doing the division between this current distance by this distance that I calculated outside for this convex hull, which will give you some percentage from 0 to 1, like 0 to 100%. So if it's close to 100%, it's close to the outer edge. If it's close to 0, then it's close to the center point. And that's how I'm going to define whether the point is close to the center or not. If it's close to the center, I want to stop these curves to grow by making the scale equal to 1. If it's close to the outside, then I want to allow these points to grow, so make these bigger, more than 1. Alright, that's what I want to do, and let's get that. So first of all, we need the center of this convex hull, which is a detail from second input called center. One of the things that I need is the minimum distance from the detail again from the second input. Okay, then what I need is the current distance from the center to the current point position, which can be calculated by distance function between the current point position to the center. Now by dividing the distance by minimum distance, you should be able to get the value in between 0 to 1, and this value will give you an information whether it's close to the center or close to the outer line, right? There is a chance that it goes over 1 because what I get from the second input of this detail, the minimum distance is the minimum distance. So if I use the maximum distance, the maximum is always equal to 1 for this ratio, but since I'm using minimum, there is a chance that there's the value is going to be more than 1. So for the value that is more than 1, I'm going to clamp that to 1. Okay, now implicit cast from vector to float. Okay, I did it again. This has to be float. Alright, so in order to clamp, I'm just going to use a fit function for that. Scale value is equal to fit this ratio, which I assume which is in between 0 to 1, but if it's within like 50%, let's say if I want to stop growing, if the point is in within 50% of this distance value, then 0.5 to 1.0. So from 50% to 100%, I want to make the scale to something like this. So if the ratio is less than 50%, meaning if the point is too close to the center, then keep all the scales to equal to 1. And from 50% to 100%, gradually increase the scale from 1 to 1.03, which I could use this one instead. And if it's above 1, then clamp it to this value. And that's what it does. Okay, now that I got this new scale, dynamically changing scale, let's replace it with the uniform scale value and see what happens. See if I can avoid growing inside the inner curve. Hopefully. Okay. So you see that at some point the points that are close to the center stop pushing to each other, just pushed by the outer lengths, but this itself is not really growing. So it at least is try to keep the shape a bit better than before, trying to create more circular shape than before. Still, I do see some pushings, but way better than before, I guess. Now these are the types of the value you could try to control to see what kind of different shapes you could get. I mean, this is just a setup for myself. So for yourself, maybe you could create totally different properties to create different shapes. For example, you could also dynamically change the stiffness of the bending as well, which might create more interesting shapes as well. Initially, if I make this 10, make it harder, you're not really seeing the shape change much. And not so much of a pushing as well. Which is also interesting. So combining this stiffness controlling as well as the scaling of the stretch might give you more control over the shape. Okay, getting slower. Okay, I do like this shape, but I'm gonna keep this to 1 for now. And so I think it's good for this stretch scaling. Now let's see if I can also dynamically change the bending value as well. Okay. And let's see what I was doing here. So previously I was setting to constant value equal to 0. And let's see what kind of difference it will make by changing this value to something different value like 30. See what happens. If I make it to 30, it's also interesting. It's constantly creating some kind of a split, trying to keep the angle between the edges 30 degrees, creating this kind of a somehow interesting chain shape. Yeah, it's interesting to see. If I make this higher, like 90 degrees, what would happen? Okay, getting smaller and going. If I make this 10, we'll give you a smoother curve, a longer arc. Yeah, like it. And I think it might make more sense to have a larger arcs inside and smaller arcs outside. So maybe I can also gradually change this angle rest lengths based on the distance from the center. Okay, let's try this out. So in order to access the distance, I can just do the same as I did for the scaling. Connect this to the second input. Let's copy some of the part like here from the scale to the angle. This and I can create a parameter angle by using a fit function again for this ratio. And for this one, maybe I can also define the minimum to 0 to, I don't know, 1. Maybe I can control this by parameter later. And the minimum, so if it's close to the center, I want to make the arc length or arc radius bigger, so the angle, I want to make the angle flat as possible. So 0. If it goes outside, then maybe I can make it smaller arcs. So let's try with 30 for now. If it's close to the edge, make this 30. Okay, and let's see what happens with this setup. Replace the rest length with this angle. Let's see what happens if I play it. Okay. Now it's getting horizontal, so I guess it's a bit hard to see where is the center, but I can see that the arc length somewhere close to the center is bigger than outside. But maybe I might have set it too small as our arc length, so let's make this 10. See the difference. Okay. Interesting. This might actually look really good in terms of my goal. Yeah, I think I really like it. For outside, it does give you smaller arcs, but inside try to keep the bigger arc as much as possible. And the growing is kind of stopped inside, so let's try to keep the shape as it is as much as possible. It does change a little bit, but because there is a push from the outside to the inside. But it looks pretty nice. Okay, so there are many things you could do with these like constraints. As I said, you could also change the stiffness over time as well to see the differences. Maybe I can also try that as well. Inside the angle, I could also control the stiffness based on this ratio, maybe. Stiffness is equal to fit ratio 0 to 1 to, let's say, currently the stiffness for this bending is using 1 as a uniform value. So let's say I want to make the stiffness inside the curve bigger and outside smaller. So let's say let's have some exaggerated value, like from 10 to 0.1 from center to outside. See what happens. So let's remember what we are seeing right now. And if I play it, oops, forgot to set this to a attribute. Okay, let's check. Go to the geometry spreadsheet for the primitive, and on the stiffness, okay, I do see those dynamic values, and hopefully this will change something as a shape. Okay, let's see. So smaller stiffness means softer physical object. Larger stiffness means harder to bend, more like rubber pole. Okay. So yeah, as a result, kind of see more controlled shape. Something I kind of wanted to see, I think. Yeah, looks pretty nice. Okay, yeah, I think I like it. So I'm gonna stick with this setup for now. Maybe the stiffness was a bit too small for the outside, but I'll come back with the global parameters so that I can control outside the solver. Okay, so let's say I'm good for now with these setup. Now, these are the main step that I have tried doing, you know, in order to control the curve. Now, all the things left out is to try to use this curve in order to make it as a three-dimensional branching shape. So what I mean by branching is that if you follow from the first frame to the end frame, you could kind of see that there is a bunch of like circular shape starting to happen, which makes it look like a branch when you extrude it into 3D. Especially if you extrude from this shape to this shape, more like a CT scan, right? So in order to connect all these curves that you have just simulated, it's pretty easy. You just need to use something like, there are many ways, but one of the easy way is to use the trail with output geometry outside a Vellum Solver, and set the trail length to the current frame, which will give you a list of curves from the first frame to the current frame, which I right now in. right? Now every curve is in the flat position, so you do need to raise these curves upward in order to connect to create the lofted geometry, which is also pretty easy. You could just use something like primitive wrangle or for each loop to raise these curves up based on the primitive numbers. Okay, so let's do that. So you could, in order to move this up, first thing you do need is the number of primitive, which can be retrieved from the prim num. And in order to move each point for each primitive, you can access each point from the primitive, just like that. And if you think this moving is too slow, then instead of primitive, you could also use points. In those cases, you do need to find out the corresponding primitive number from the point, which is not that hard to do. Primitive for this point is point prims 0 pt num 0, since there's only one primitive for each point. Okay, so this will give you the primitive number for this point, which primitive the point belongs to, and in total, the total number of primitives can be retrieved by using n primitive 0. Right? Then you could get the normalized value for this primitive by dividing like that, which will give you a value in between 0 to 1. And there is a meaning for this, because by creating a value like this one, you could control how you want to array those contours, not just by moving linearly, but if you want to make it like with the log scale, or using a custom curve map, something like that. Let's say you want to use the curve map to control the position of these contours. You could use the ch ramp for this f value, which is in between 0 to 1 for now. Then you can multiply it by the total height. Then finally update the point position, in this case the y value, with this f. And let's see, let's set the height to 10. Okay, well, it was other way around, I guess. I wanted to start from this circle, but it goes out other way. But looking like a skeleton shape, it looks pretty nice already. Now, right now it's linearly moved. All the curves has been moved linearly upward. But by using this ramp parameter, make this be splined. First of all, let's make this upside down, like that. And then using these curves, you could create customly layouted shape to make it look more like a tree, more like a bowl, and so on, or more customized, interesting shape. Weird shape, which might also be interesting. Let's go with this tree-like shape for now. Let's make this a bit more higher, like 20. Just like that. Okay, so this is right now just a contour, so let's connect these curves together to create the geometry, and that is also easy. You can just use polyframe, poly loft. And that's it. And maybe I can use a reverse. Seems like it's flipped. So let's flip it back. And this is what you get. Let's make this shading to matte cap to make a little bit neat. Okay, so controlling this height value together with this curve map should be able to see. Oops. Be able to see many types of geometry made. Okay, this made a weird shape, obviously. Maybe I shouldn't do like this. Something like a ball-like shape and so on. Looking from the bottom, looking from the top. It's pretty interesting. And since everything is flat, I mean all the contour is flat, you could also use something like polyfill with the unique points on. You could create didn't really work. Didn't really work. Triangles? Nope. Okay. And make this unique points. Now you could also make a cap to this geometry because it's flat. Create some kind of organic vegetable like shape. Okay. And by changing all the parameters I have explained inside of Vellum Solver, you could create a bunch of different geometry with it. And this is just one way to visualize the output from this Vellum Solver, and I thought this visualization looks really interesting. It looks like an organic shape, so this is one thing that I wanted to show here today. But the main thing that I wanted to show honestly is much more of how you could control the Vellum constraints using wrangles dynamically, which will give you a whole lot of options to create different kinds of results, just like I'm showing. Can you... Okay, let me look at the comments. Can you round the cap somehow? This one. Maybe not really straightforward. I don't think the bevel works for this one, so yeah, I don't think this will going to work. It's a bit too complex. Oops. Shit. I guess the easiest way I could think of is to use a VDV to round these shape up. That might broke the topology somehow, but which will be one of the way. If you carefully create the geometrical structures, you could use a polybevel or something like that, relevant to that, I think. But for a quick process, I think it's not the way to go. I'm trying to delete this. You could potentially do a fake bevel using your profile setup before. I guess, yes. You are right. You could somehow, let's say, for the last edge, you could use some kind of a offsetting functions for the curve to create a bevel-like shape for sure, I think. But some part like this one, you have really thin edge, really thin width, so you gotta be careful about how much you could bevel. The bevel amount has to be less than the half of this width, which is not that much, or the minimum width of this whole thing. If you want to do that, you could do that for the last edge or last curve for this things, for this contours. Let's see. I could just pick up the last one, probably. I don't know if it's the first one here. Yep. Then create an offset curve which goes inward, which I'm not sure if it's straightforward or not. If I calculate the poly frame for this one, for a bitangent, okay, doesn't. If I look at the tangent vector, okay, so this is the direction. What about this one? Okay, so I could probably use this bitangent, which currently is in the opposite direction. I guess I'm gonna go to the opposite direction of this bitangent vector, I guess, for the offset. So I'm just gonna quick prototype for this one, because I'm not sure if it's gonna work only with the wrangle. Yeah, voxel Weshman smooth. Yeah, the VDV, using VDV is just the simplest way to do it. If you continue the simulation in a way that makes it shrink, that makes a bevel kind of. Maybe, but it's not really like precise. You can't really precisely control the physics simulations just like you do for like a geometrical operations with the vectors. You can't really, because there's a collisions being applied to the physics simulations, but there might be a way to control it precisely. Maybe. Not really sure how. Well, let me just show you the easiest way, I guess. The BDV combine, BDV convert, or BDV from polygon to convert this whole shape to BDV first, to some resolutions, then BDV convert back to the polygon, which might not be good enough in terms of the resolutions. Also it kind of connects, create the bridge. So let's make this resolution smaller, and in between I can create the BDB smooth SDF to make it smoother, to create kind of a smoother edge. Now I still have those bridges, or I still have this kind of a breaking holes when it is too thin. So you gotta keep this thing smaller and smaller in terms of the resolutions, makes it slower and slower to calculate, of course. At some point might give you a better result. Try to make this a bit more iterations for the smoothness. Maybe. I mean, this is just one way, but the downside of this is that it gives you a whole bunch of vertices, which is not really ideal for most of the cases. Too many vertices. Well, even though I can adapt it, still it's not that clean in terms of the topology. Maybe in some case it's fine, maybe in some case it's not sure. Alright. If you switch a completely different kind of solver on some point, that type of control. I see. Yeah. If you could switch to a sub solver instead, then that will give you a chance to control geometrically, I guess. Yeah, that's, I think, definitely one way to do it, for sure. Okay, so where was I? So this was just, I was just trying to offset it with this normal direction just a little bit for amount of time, let's say for getting the iteration value. And iteration, and let's try to define the total offset value, which should be less than, as I said, the half value of this edge width, which I don't really know. So let's make this small, like 0.1. Could be 0.1 because the collision length is around 0.1. So half, so 0.05, I guess. It could be the maximum for the bevel width. Then the actual offset is then the multiplication between the iteration divided by the number of iterations, which will give you another value in between 0 to 1 throughout the for each loop. Alright, so and yeah, I'll just go with it. Then move the point to the normal direction, to the negative direction, multiply by offset. Which will give you these offset value. Let's check. Okay, so yeah, looks like there are no intersections. Hopefully. Okay, now I can raise these curve up based on this this iteration value. Maybe I can make it as a variable. Like that. Oops. What did I do wrong? Okay, I think I did something wrong here. No semicolon. Offset. I don't really need normal. Okay. And I also want to move this upward, so set 0, 1, 0 multiplied by f multiplied by height of the bevel. Could be the same as the offset, so I'm just gonna multiply by offset. No, actually I can just say 0 offset and that's it, which gives you a linear shape. So actually that's not really what I want. I want to have something more of a curvy shape, which in this case I could use trigonometry in order to define the height, I guess. So I have the width, I have the x value, which is this offset. So from this x offset, in order to get the angle to define the height, what I could do is yeah, I'm just gonna recreate it, not by using this offset after all. Okay, what was I? Why did I get notification when you started stream? Well, not sure why. That's too bad for me too. I think there is something like a bell mark or some notification icon somewhere on YouTube to get the notification always. Not sure, probably. Well, you can call me in any name. Some people call me Jun, Jun. That's also my father's name, but some people call me like that as well. Where was I? So so I need to define the x and y position for each of those points using trigonometry. Right, then in this case we are rotating 90 degrees, right, from 0 to 90, and we don't know how many points we have. Let's say if we have 7, we want to divide 90 degrees with 7, so rot angle pi multiplied by 0.5 will be 90 degrees, divided by, multiplied by iterations, divided by the number of iterations, in this case f, will give you a value in between 0 to 90 degrees in radians. Okay, now you can get the x value with cosine angle. Is it Yeah. And float y will give you a height value a height value can be given by calculating sine of this angle starting from 0. And I want to use those values in order to define the positions, in order to define how it should move. Okay, now the x is going to be replaced with this offset. So instead of just multiplying f to the offset, because I don't want to linearly move to the offset direction, but instead I want to multiply this by x value. And actually it should start from 0, so maybe I can instead use y for the horizontal direction. And for the y, it also starts from 0, I guess. So I guess the angle is not from 0 to 90 degrees, but let's think. Wait a minute. Well, it's still okay with x, but instead I'm gonna say 1 minus x. And for a y direction, I'm just gonna use this one, y. Right, and see what happens. Oops. And y multiplied by height or offset. And hopefully I get some roundy shape. Yep. I guess I did. Hopefully. Looks like it did. Okay, now it's time to replace the last curve with this updated curve. So I just need to merge these in the right order. Just delete the last one and connect like this. I don't know if it's in the right order, so I'm just gonna sort it out brute forcefully based on the primitive y direction. Then see if I can loft it together. And something weird happened. What did it wrong? Maybe it's due to the normal direction, or I don't know. Okay, let's see what's going on here. Not really sure what's happening here. If I recalculate the normal. Okay. So it looks like it did give you some kind of a bevel shape here. I kind of didn't really need it to reverse in this case. Then if I do the polyfill, yeah, it filled up nicely. Okay, so in this case I didn't really need it to use VDV after all, which took a little bit of time to solve, but you have less number of vertices for result, which is nice. Okay, well, this is just one way. I mean, I'm not sure if this is ideal or anything. I'm just gonna keep it as it is so that when I save it, some people could check it out, see if they can use it for themselves. Okay, maybe just keep this thing here as well, just as a reference. Okay. So 7 was too much, maybe 4 is enough. For this kind of low res geom. Alright, so that's good. That is good. Let me try to organize this a little bit by collecting all the parameters that I can control later, globally. Normally I create null node under the geometry network and collect all the parameters that I can control for the shape for the geometry inside this null node, so that I can come back to this one to control everything that I want to. Something like maybe this doesn't really matter. This one could matter, so initial offset, smooth, create a separator. Okay, and I didn't really set any things right here. Let's go inside, see what kind of parameters that I can bring up. First of all, this one, of course, the resolutions of the curve segment lengths. Okay, property Pscale. Now this could, I'm not sure if this is necessary to be parameterized. This should be bigger than this length, so I'm just gonna copy this value, paste it right here, and just make sure that it's bigger by multiplying by 2 or something. And that's it. Okay. Anything else? Nope, not for this one. So for going back to the constraints, so convex, attribute promote, distance, attribute distance, scale. Okay, so this is another parameter that I can control here. Constraint scale, or string scale, growth scale, from 0 to 2. Okay, for this angle, I guess there are a bunch of parameters you could control for this one. For example, I'm using a constant value here like 10, but this could be parameterized for sure. Max out angle, and this one could be a minimum, or I could say outer angle, and this could be inner angle. Right, which makes more sense. And how about this one, stiffness? So this is the inner stiffness, this is the outer stiffness, right? So inner stiff, and this is the outer outer stiffness. Okay. Okay, it's being reset. So it was from 0 to 10, I think, and the inner stiffness was 10. Outer stiffness was, forgot, 0.1. Yeah. And then let's bring all these. Okay, everything becomes capital letter in the first letter. Well, doesn't matter. And scale. Maybe I could also control this one as well. The clumping, the minimum clumping for the scaling. Min scale, min pos, min. Hard to name this thing. Scale, min ratio. I don't know. Min position. It's pretty hard to name these things. Scale, min, pos. Growth. Right. Well, actually, I could also make this as a parameter. Yeah. Because there is a chance that you want to grow inside and not grow outside as well. I mean, there are many ways you can control it. So, inner scale. Then this should be outer scale, I guess. Outer. Or I'll just gonna rename it. Outer scale, inner scale. Going to this one is outer scale. Right. And also promote the inner scale. Make this come here. And this one is outer growth scale. This is inner growth scale. Inner growth scale. Right. Now, well, this could also be parameterized, but I'm just gonna leave it as it is. You could just do it by yourself if you think you need it. Okay, I think that's it. Inner scale is 0. No, is it? No, it should be 1. Okay. Oops. Okay, so I think every parameter has been transferred inside this constraint solver. Go back. Right. Go back outside, and everything left is for creating the geometry. So height. And this shape. Branch shape. What else? What else? Oops. Seems like it's recalculating. Well, wasn't my intention. Okay. And maybe if you need a bevel, you could have a bevel contour num. I don't know if it does need to be parameterized or not, but it's least important parameter in this project, I guess. Okay. Seems like it's recalculating over and over again. And what else? That's pretty much it. Okay, so let's check those parameters to see if it's gonna work correctly. Okay, going back to the controller. Most of the control that I want to do is about these curve simulations. So first of all, if I raise up the curve segment, making less low res, let's see what happens. Still give you a decent result, I think. I think I still like it. Yeah. Yeah, nice. So, making curve segment higher wasn't that bad. The inner growth scale, this is to control how much it grows on the center. Based on this positions scale. So this should be more than 1. Maybe it's from 0 to 2. I mean, you could also decrease the value, like make it less than 1 and see what happens. Kind of curious how what's gonna create. So my assumption is that if it's getting close to the center, the length becomes smaller. Okay, so I guess that's what happened right now. It's pulling back to the outside. Okay, making weird intersections. Some weird result. Yeah, at some point it gives you some repulsion or something somewhere around here. Looks interesting, but not really what I want. Let's keep this as it is. Okay, so growth scale minimum positions. If I set it to like 0, then gradually everything is starting to grow. Makes it less possible to keep the inner shape, because everything is constantly growing at some rate. Even if it's close to the center, it will somehow crush together to create more like a heavy or snake-like shape. Yeah, well, still looks nice. Although I'm gonna keep it 2.5. So inner angle 0, outer angle 10. It was to control how much curvature you wanna, or what's the angle for the outer edge and the inner edges. If it's close to 0, the edge tries to keep flat. If it's more than 0, then it's try to keep at some angle. 10 is more like an arc. If it's make it 30, then it's more smaller arc shape and so on. So if I make it 20, you'll see more smaller shape on outside. just like that. And if you make it much smaller, like 50, see much smaller shape. Starting to see something really different. Interesting. Quite interesting. Though not what I want. Okay. So inner stiffness and outer stiffness, this is also important as well. This is to define how hard the curve is inside the curve, or on close to the center and outside to the center. So right now it's pretty hard inside here, but if I make it much harder, let's see what happens. So it merely bends inward. And it really bends well outside. It still gives really interesting shape. Clearly a lot similar to an arc-like shape inside, and a bit more randomish or a bit smaller bunch of curves outside. Nice. And this is just a condition using the center position to calculate distance, but there are like many ways to set the conditions, not just the distance to the center, but with your choice. And there's also a chance that you could apply this pattern not on just on the flat plane, but maybe on the 3D surface as well. So there are many things you could still try out with this simple settings. Alright, so I do like it, so I'm gonna keep it as it is. Height. So this is for the after you are good with those simulations, it's time you could make it 3-dimension by connecting all these contours together. Now some part is not that smooth, especially those here. That is because I guess it's moving too fast at those positions. I'm guessing every primitive has same number. I mean, pretty yeah, it does have a different number of points. So the one reason why it became a bit low res round at the top is because of setting the curve segment length to smaller number, I mean bigger number, make it a bit low res. So keeping this to the smaller value should enable you to get a bit smoother surface. If you want to avoid that, that's one way. Another way, again, you could use something like VDV or apply like attribute blur or smooth to clean up the surface a little bit. If I make this to 0.1, which will give you a slower simulation speed, but should give you a bit smoother result, I think. Hey Jorge, thank you for joining the Patreon. Really appreciate it. Okay, as you can see, it's a bit slower. Slower means there are much more points to calculate, since I made the resolutions, the curve segment half. So the calculation time becomes 2 times slower. Okay, so let's see how it goes with the 3D shape. Hopefully it is a bit smoother. Yeah, a bit smoother. I still see some bumping, but better than before, I guess. Now you could also try to smoothen out before making the cap somewhere around here. Using the smooths to try to smoothen out the surface. See if it can fix. Maybe just a little bit. Scale dominant. Not many difference. Curvature dominant. Not so much. If I look at the edges itself is not that bad how it's aligned. Yeah. So I guess it's okay. Just gonna keep it to 20. All right. Okay. So this is what I get. And hopefully you would try out with other like parameters to test out all those different geometries. It does give you tons of interesting shapes for sure. So I think I'm going to end this live soon. Let me know if you have any questions or if you have any feedback. If you want me to do anything else with this, let me know. If not, I'll think I'm gonna end this. One thing I could show you while I was testing how I can visualize this one is using this curve as a guide to mix the color somehow, like a fake color mixing, just like the fluid like colors. I mean, it's not really like a smooth fluid simulations, but I could use this as a guide, like a flow guide for the color mixing. Meaning going to what I tried is to use the UV of this curve as a guide to pick which color I'm gonna use in between the gradient, right? So I'm gonna show you what that means. So first I am going to create some grid covers this curve from small to large. I think around this shape, around this size is good enough. Okay, let's make this a little bit bigger, like 15. Right? And I want to use this grid as a picture canvas where I attach the color to each point. And for each point, I'm going to look for the closest position to this curve and get that UV value and use that UV to sample the color from the gradient value to create kind of a fake coloring, fake color mixing. I'll show you what I mean. So getting the curve geometry from this output and sample. So what I want to do is for each point on this grid, I want to look for the closest point position on top of this curve by using XYZ dist. Now this XYZ dist function gives you two output value. One is the primitive and one is the UV for this primitive. And UV is the one that I want to use this time. Now in this case UV will give you a primitive UV, and there's only one primitive here, the final curve. And UV is always in between 0 to 1 for the curve, for a U value. There's no V value for the curve. So what you get is the value applied inside this UV, and only the X value of this UV is changed from 0 to 1, so I can directly use that value to sample some color value. Okay, so pick that color value as an attribute. Just the X value. And then use some color node together with some ramp parameter, using something like, I don't know, what's the interesting one, like this one, magma, with attribute call for the point. As a result, yeah, I should change the shading to probably smooth shaded. There you go. What I get is sampling from the closest curve and try to color that. Try to color using that UV U value. Now, since the curve length is really long, so what I see as a color is pretty small. How do I say it? Small regions. So in order to make it a bit more organic, like a mixed up color, what I'm going to do is to first of all make this loopable by bringing this to the left side, then copy some of the handle, this one, copy this one, finally copy this one. Okay, now going back to the UV sample. Right now the value is in between 0 to 1, but I can increase this range by multiplying it by some higher value and then get the remains of 1. Then you can get the value from 0 to 1 3 times. 0 to 1, 0 to 1, 0 to 1. We'll have more color range, and by increasing this value, start to see more mixes, which is another way to visualize this curve network somehow. In some other ways, sometimes it looks interesting, sometimes it looks weird. In this case, it doesn't really look nice. Well, anyway, some cases it looks really cool. For example, Let me screenshot this one so that I don't forget the nicer setup. For example, if you are okay to change the shape inside as well, then one way you could do is to keep the growth scale same uniformly. Also set the inner stiffness and outer stiffness the same as well, just like we did previously, and then also set the angle for inside and outside the same, like 5 and 5, which will give you a uniform geometrical change which pushes these curves in without preserving any circular shapes, creating more like a snaky like shape which is still okay. And since the lengths of the curve become longer and longer, the simulation takes a bit longer as well. In those cases, maybe I could have set this curve segment length to larger value to make it less expensive in terms of the cost of the simulations. Okay, let's say I'm good with this one. Now, compared to the previous one, I have more curve tangled together. And with this one, the color looks more interesting. Like these. If I set this to 3, let's make this parameterized. So with these set up, the curve will create some interesting coloring map, because you have a smaller gap in between the curve and the curve in between the curve close next to each other has different U value, which will give you this kind of a mixture of colors. Yeah, I also like this one. Although, what I wanted to see is those three-dimensional shape, and with this shape, the three-dimensional shape looks... I actually didn't really test it. Let's see how it looks like. Okay, the cap failed, so... Okay, something failed. Maybe the... this bevel might have failed. Let's try to go back, see if the bevel is doing something wrong. Probably, I'm not really sure. Let's see if I skip adding the bevel, what happens. Okay, so this bevel part was doing something wrong, so this one looks okay. Okay, so this still looks interesting in terms of the shape. Starting to look more like a cutout broccoli. If I set it to green. Yeah. Okay. Well, that's pretty much it. What do I do with this bevel here? let me see if I can fix this, and if not, I'll just leave it as it is. So this should be the one that's failing somewhere around here, obviously. And why is that? So for some part it's okay, for some part it's totally breaking. Maybe the offset was too close to the edge. If I ever make this smaller. No. How's this? Seems like it did. So maybe by changing this value you could somehow. So I guess there are some places where the width is really thin. You needed to avoid intersecting. So 4 didn't work. Nope. So somewhere around 3.5 or 3.7. Yeah. It's pretty manual. Okay. Anyway. In this case it worked. Alright, so I guess I should also parameterize this bevel offset. And I'll finish this. Bevel. Where is the bevel? Here. Bevel offset from 0 to, I don't know, 0.1. Okay, so that's it. Thank you very much for watching. I guess I don't get any questions so far looking at the comment, so I think I'll just finish it right here. As always, I am going to upload the file that I've just created, which is this one, to the GitHub and upload it as soon as possible, as soon as I finish this live stream. Then paste the link to the video description page of this YouTube live archive, which is going to be archived. And I'm also going to upload the file itself to the Patreon page as well. If you are joining the subscriptions, I am much appreciated. If you're new, please consider. But it's all free to watch all the tutorials. Anyway, thank you very much. And hopefully I can do the tutorial next week as well. And this is the 92nd, so I am 8 episodes left to have in total 100. So yeah, can't wait for that. Okay, well, thank you very much as always to be impatient to finish watching this one. Hopefully you have learned something new. I did learn something new from your feedbacks, so thank you very much, and have a good night, or have a good day, have a good morning. I am going to sleep right after this. Okay, night. And I am going to end this.